Let's talk about the Fibonacci sequence and finding Fibonacci numbers. So what the Fibonacci sequence looks like is we start off with a 1, and a 1, and then for all the following numbers, every number in the sequence is going to be the sum of the previous two numbers in the sequence. And so the third Fibonacci number is going to be the first plus the second one, which is 2. The fourth Fibonacci number is going to be the second plus the third Fibonacci number, which is 3. The fifth Fibonacci number is going to be the third plus the fourth Fibonacci number, which is 5. And then we're just going to add these two, which gives us 8. And then we're going to add these two, which gives us 13, and so on. So we are going to define the Fibonacci problem as this. Given a number n, find the nth number in the Fibonacci sequence. In the Fibonacci sequence. And one thing to note that this is one-based indexing. In other words, this is the first Fibonacci number, this is the second Fibonacci number, and so on. And so it seems very natural here to define some sort of method or code that does that solves the Fibonacci problem. It seems really natural to define it recursively, given that the Fibonacci number, or the Fibonacci sequence, is defined recursively, right? The nth Fibonacci number is the n minus first Fibonacci number plus the n minus second Fibonacci number. So that's exactly what we're going to do. Let's define f of n. And f is going to stand for Fibonacci. So let's start with the recursive part first. We're going to have that f of n equals f of n minus 1 plus f of n minus 2. Right, and like we saw with the factorial problem, we're going to need some sort of base case. And here we are going to need two base cases, which are the first and the second Fibonacci numbers. So what we're going to say is that if n equals 1 or n equals 2, return 1. And so that is our code for the Fibonacci problem, for solving the Fibonacci problem. And in the next few videos, let's look at how to solve for the runtime.